Hello and welcome to Algebra 2. Today we're talking about Chapter 11.2, Arithmetic Sequences and Series. So in 11.1, it was a general, any kind of sequences and series, and today we're going to concentrate on arithmetic ones. So what makes a sequence an arithmetic sequence? It is the fact that there is a common difference between the terms. Okay, or there's the same distance between all these consecutive terms, and so it is called the common difference. We use a lowercase d. So for instance, if we said 2 and then maybe we went up by 3 and then we went up by 3 and we went by 3, right? If every time you went up by 3, then d would equal 3. And so we have a very specific formula then for writing that rule, and it's a sub n equals a sub 1, so the first term, plus n minus 1 times the difference. And so make sure you have that written down, and in a few minutes we're going to use that. So the first thing we want to decide is just, are we dealing with an arithmetic sequence? And so you're looking for that difference. So here it looks like we added 4, and we added 4 more, and then we added 2. So no, that's not. Okay, why don't you spend a second and see if you can do the next one. Pause the video. So I get the next one is yes. We're adding 6, adding 6, adding 6, adding 6. So that looks like yes, it is arithmetic. So let's go back to that rule we wrote down. And so to refresh your memory from a minute ago, a sub n equals a sub 1 plus n minus 1 times d. And so first of all, you always need to make sure you are dealing with an arithmetic sequence. So this looks like we are adding 15. Okay, and then from 47 to 62, adding 15 more. Alright, so that looks like it is arithmetic. And so the first thing we want to do, we're asked to do two things here. First thing is to write the rule for the nth term. So we leave this a sub n. A sub 1 is 32 plus, well, if it's for any nth term, n stays in, that's an n, minus 1 times that common difference, which is 15. And then I want you to simplify this. I know that's a lot to ask, but you can do it. Distribute 15n minus 15. Clean it up a little bit. We're going to have 17 plus 15n. So there is our rule for the 15th, or for the nth term, sorry. And then specifically it wants us to find a sub 12. So a sub 12 is going to be 17 plus 15 times 12 because we made n be 12. And punch that into a calculator, we get 197. There is the 12th term. Okay, so our next order of business is it gives us the 20th term, and it gives us the common difference, and it wants the rule. Well, let's look at our equation again. A sub n equals a sub 1 plus n minus 1 times d. Well, what do we have? So let me ask you, do we have a sub 1? No, but you have to have a sub 1 to write the rule. So for the nth term, you need a sub 1 and you need d because n stays in. And I don't know that. So let's see here. Well, I specifically know the 20th term, so I know that the 20th term, let's do this, I know a sub 20, well, a sub 20 is still going to equal a sub 1 plus, so this would be 20 minus 1 times d, but even more specifically than that, I know a sub 20 is negative 111, so you could really skip to this step. A sub 1 plus, so n is still 20, 20 minus 1, and I know the difference it told me was negative 6. And so now I only have one variable. So negative 111 equals a sub 1 plus, so it would be 19 times negative 6, so let's do one more step then, equals a sub 1 minus 114. Adding 114 to both sides, we get a sub 1 is 3. And thus my rule, so let's see here, a sub n equals a sub 1, which is 3, plus n minus 1, because we're back to the nth term, times negative 6. And remember, you're going to clean this up a bit. So I should probably put a minus there. Minus 6n plus 6. So a sub n equals 9 minus 6n. So in order for us to write our rule, we first had to find our a sub 1. So you just need to find whatever you're missing. Two terms of an arithmetic sequence are a sub 5 is 10 and a sub 30 is 110. Write a rule for the nth term. Well, now we're going to miss two things. So let's look here. I'm going to write it up top. A sub n equals a sub 1 plus n minus 1 times d. Hopefully you can read that kind of. So, do we know what d is? No. Do we know what a sub 1 is? No. If you have two unknowns, to solve that, you must have two equations. So, our two equations are our two terms that we know. So, if I put in a sub 5, a sub n becomes 10 equals a sub 1 plus n, well, this is the fifth term, times d. And if I put in the 30th term, a sub n is 110 equals a sub 1 plus 30 minus 1 times d. Okay, let's do a little bit of rearranging here. 10 equals a sub 1 plus 4d, and 110 equals a sub 1 plus 29d. And what I would do is I would multiply, and put it over here, I'd multiply the second one by negative 1 and get a negative, a negative, and a negative, and add these together, and we get negative 100 equals, because this is a system of equations, negative 25d divided by negative 25, d has to equal 4. And then if we do 10 equals a sub 1 plus 4 times 4, that's 16. Subtract the 16, a sub 1 has to equal negative 6. So my rule has to be a sub n equals a sub 1 plus n minus 1 times 4, which is negative 6 plus 4n minus 4. A sub n equals negative 10 plus 4n. That is my rule. I like how my n's don't look like n's. So sorry. Okay, so now that I have a rule, so one more time I had to do two equations because I had two unknowns, and that's how you solve for two unknowns. So now that I have a rule, can I find n when a sub n is negative 2? Well, so that's negative 2 equals negative 10 plus 4n. And yes, I think we can do this. Solve for n. So we get a equals 4n, n equals 2. There we go. So the next thing we're going to look at is arithmetic series. So remember, a series is when we add it up, we sum it up. So the expression formed by adding the terms of an arithmetic sequence, that's an arithmetic series, and we want to sum up the first n number of terms, and so we take how many terms there are times that's the first term plus the last term divided by 2. So let's see if we can do that. So consider the arithmetic series 2018, 16, 14, etc. We want to find the sum of the first 25 terms. Well, for you to use the equation you just wrote down, let me write it down again, n times s sub 1 plus s sub n. Those are a's, so sorry. I know you're probably going, but I wrote down a's. A sub 1 plus a sub n over 2. So do I know n? n is how many terms? So I'm doing 25 terms. A sub 1 is 20. Do I know a sub n? I do not know a sub n. A sub n is my 25th term. I need to find my 25th term. So here's what we do. We use our a sub n equals a sub 1 plus n minus 1 times d. And we're looking for a sub 25, so we're just going to call it a sub 25. Well, a sub 1 is 20 plus, if I'm looking for the 25th term, that's going to be 25 minus 1. And do I know the difference? Look right here, what are we doing? Minus 2, or negative 2. So, 20 plus 24 times negative 2, 20 minus 48, negative 28. There is my 25th term, negative 28. And then we're just going to compute that. So it looks like we have negative 8 divided by 2, which would be negative 4 times 25. The first 25 terms add to be negative 100. And that should make a little bit of sense. We're only looking at 4 terms so far. By the time we get, and we're going down 2 every time, by the time we get to the 25th term, we're going to be quite a bit negative and have been negative for a while. So our next thing is to find n such that s sub n equals 760. Well, s sub n is on the left-hand side. So I would know that negative 760 equals n times, well, I know the first one is 20, but do I know the last term, right? Plus, do I know a sub n? Well, I don't, because I don't know how many terms I'm going out to. So we need to find a sub n. Well, a sub n is just my formula, right? Look up here, a sub n is just my formula. So it starts out with a 20 plus n minus 1, because I don't know what n is, times negative 2. So this is 20 plus, nope, minus, plus or minus, whichever one, minus 2n plus 2. So this is 22 minus 2n. So my very last term is 22 minus 2n. And notice this is okay because in all of this that I have here, I only have one variable, and it is n. So how to solve this? Well, if I were you, I would probably start out by doing a little 42 minus 2n over 2. And because everything there is divisible by 2, that's going to be 21 minus n, which is going to give us negative 760 equals 21n minus n squared, in which case we have a quadratic. So let's move everything from the right-hand side over to the left-hand side because we want a positive n squared. N squared minus 21n minus 760 equals 0. And this does factor. I will factor it for you. Save you the pain of trying to figure out what this is. Minus 40 plus 19, which means that n equals 40 and negative 19. Okay, great and all. Remember we talked about that n being a term number really starts at 1. Some of them start at 0, but can you have a negative 19th term? No negative 19th terms, so we want the first 40 terms. Okay, one last example here. Find n for the series 100 plus 110 plus 120 plus 130 such that the sum of them, that's what the S is 600. Okay, so this is exactly what we just did, so let's go through it just one more time here. We have a formula. In fact, when I said this is exactly what we just did, this was the second part of the last example. So I have an S sub n, it's 600. I do not have an n. I have a first term. I do not have a last term. Okay, so the first thing we have to find is what is my last term, and that I get from the fact that a sub n equals a sub 1 plus n minus 1 times d. So a sub n equals 100 plus n minus 1 times 10, that's my common difference, 100 plus 10n minus 10, so it looks like we have 90 plus 10n. So if we insert it over here, 90 plus 10n, do a little bit of simplifying, n times 190 plus 10n, and then that so nicely divides by 2, so we're going to have 95 plus 5n. With a little bit of distributing, that is 95n plus 5n squared. And we want to set our quadratic equal to 0. And this time we're going to move the 600 over because I want that positive. And you know what else I'm going to do? I'm going to go ahead and divide everything by 5. N squared plus 19n minus 120 equals 0. Okay, to help you out with the factoring, it's n plus 21, and it's not a 21, it's a 24. Can't read my handwriting. N plus 24 times n minus 5. So n is negative 24 or positive 5. Well, we just talked about this. We can't have negative term numbers, and thus we must have the first 5 terms. And really quick, if we come up here, fifth term is going to be 140. So the 100, 200, 300, 400, 500, 70, 80, 90, 100. There is 600 right there. Okay, that's 11-2. Please make sure you wrote down all your equations. You might even write down some questions you have for us to go over in class. If you need to see me before then, please do so. If not, I'll see you in class. Have a great day.